Okay, so with a problem like this then, one of the first things we need to know is where on this graph are we working with? All right, so it says ice between negative 12 degrees and negative 47.5 degrees C. Well, the freezing temperature of water is 0 degrees C. Okay, so we're down below that the whole time. And so in this region then, the equation we're working with is heat energy is Q is equal to mass times the specific heat for ice times the change in temperature. That's what you have at that region all the time. Anytime you've got that on this heat energy versus temperature change and going through the physical states on this graph, anytime you're in a region where you've got a direct relationship, that means it's a straight line with a positive slope, you're going to be using this equation. That equation also fits here, and it also fits here. Okay? So that's the equation we need. Q equals mass times the specific heat for that substance and its physical state times the change in temperature. So we need to know all three of these. Well, the mass is given to us. It's 157.2 grams. The specific heat for ice is 2.05 joules per degree C per gram, and we need to know the change in temperature. What? For the temperature change? Okay, so let's just make sure we're clear about that. Temperature change is always the final temperature minus the initial temperature. Okay? So it's always going to be, the final temperature is, we're cooling it down to this, that's the final temperature, negative 47.5 degrees C, minus the initial temperature is minus 12 degrees C. Okay, and when you subtract a negative number, it's like adding a number, right? So we're, yes. So it's negative 47.5 degrees C plus 12 degrees C. Okay, and so you do get 37.5, but it's a negative number actually. I'm sorry, 35. Oh, for 35, I don't know why 30. You're right, 35. Okay, so now this is 35.5 degrees C. Okay, and you're going to put these over 1 just to make things nice and neatly arranged. It is probably very important, based on what I've seen with this class before, very important that you add and subtract your numbers vertically like this. Because very often students don't recognize, ooh, my calculator didn't give me a number in this place. If there's a 0 here, your calculator won't show it. And the only way at this point in time for you guys to recognize when a 0 at the end is significant is if you line them up vertically. So don't shoot yourself in the foot by failing to do the work on paper. Okay, this is the way I've taught you to keep up with significant digits for addition and subtraction. Please use that tool. All right? So once we set it up, then we can cancel grams, we can cancel degrees C, and we're simply going to do the math. We're multiplying everything across the top, and since on the bottom all we have are 1s, we can kind of just skip over that because dividing, or multiplying for that matter, by 1, it just gives us the same number we started with. So I've got 157.2 times 2.05 times 35.5. For this number here? Well, the specific heat for ice, did I not give you that number on your chart? Yeah. 2.05 joules per degree C per gram. Okay, you just probably, maybe you looked at the wrong one or something, or did you write it down wrong? Okay, well make sure you change that. I mean, I will give you the specific heats on the test, but you still have to know where they fit. Okay? Alright, so I got 11,440.23. Now we've canceled all the units save joules, so we have to have joules here. Now we have to round. I've got 4 significant digits here, 3 significant digits here, and 3 here. So of those measured or calculated numbers, these two have the smallest number of digits, and we need to have our final answer have the same number of digits. So we're going to count from the first non-zero digit from the left, 1, 2, 3. Those are our significant digits. Everything else is insignificant. So we have to underline the insignificant digits. It's required that you underline the insignificant digits. We need to move the decimal place. Since we're getting rid of a number in the ones place, your answer must be in scientific notation. So we're moving our decimal place to the left between the first and second significant digit. 1 place, 2 places, 3 places, and 4 places. If you don't have to get rid of a number in the ones place, you don't have to put it in scientific notation. So 1.14, rounding off everything else, times 10 to the, and this 4 here means I'm going to have a 4 exponent on the 10 joules. Does that make sense? Yes? No? Maybe? What? Ah, very good. So this should be a negative number here. That makes this a negative number, that a negative number, and that a negative number. So we're losing energy to cool it down. That makes sense, doesn't it? If we're losing energy, you'd have negative joules, because that right there is the energy in the system. Yeah. All right. Any other questions about that?